All right, we have the solutions to homework number 16 in calculus. This is number 16 through 27 in the Unit 1 Pre-Calculus Review Packet. So for questions 16 and 17, we're looking to write the logarithmic form of the expression. So I'm going to start with question 16. I have 2 raised to the negative 1 power is equal to 0.5. So the simplest way, I believe, in order to write the logarithmic form of this is to cancel out the base here by using a logarithm of the same base. So I'm going to take the logarithm, or the log base 2 of both sides of this expression. So I'm going to make both sides of this the argument of a log with a base of 2. On the left-hand side, you'll see that log base 2 and the base of 2 will cancel each other out, leaving me with just negative 1. And on the right-hand side, I really can't make any other simplifications. So I just have log base 2 of 0.5. So, in case you've forgotten how to read logs, it would be read as 2 raised to the negative 1 power gives me 0.5. For number 17, the exact same process occurs, but instead of using a logarithm with a integer base, I'm going to use a natural log. So I'm going to take both sides as the argument for a natural log, because the base of a natural log is e. So I have natural log of e to the a and natural log of b. On the left-hand side, natural log and the exponential will cancel each other out, and I'm left with just a equals ln of b. Moving on. In number 18, we're going to do the opposite process. So we're going to start with the logarithm, and we're going to get rid of the logarithm and write it in exponential form. So I start with log base 25 of 5 equals 1/2. And I'm going to take both sides to be the power of 25. That is how I would get rid of this logarithm. So what I mean by that is I will make 25 the base, and I will raise that 25 to the power log 25 of 5. And I'll do the same thing with the right-hand side. So I'll do a base of 25, and I'll raise it to the 1/2 power. On the left-hand side, you see that the 25 and the log 25 will cancel each other out. On the right-hand side, I can't really do any more simplification, so I'm just left with 5 is equal to 25 raised to the 1/2, which, since the 1/2 power just is another way to write square root, we know to be true. For 19, I have ln of a equal to b. So I'm going to do the exact same process, but instead of raising it to raising it as a power of an integer, I'm going to raise it as a power of e. So I have e raised to the ln of a on the left hand and e raised to the b on the right hand. So the e and the natural log will cancel each other out, leaving me with just a is equal to e raised to the b power. So, putting all of this together, we move on to numbers 20 through 25. So I want to evaluate or simplify these as much as possible. So here I have log base a of 1. And so what I want to know here is a raised to what power is equal to 1? Well, I can easily recall that the only way to consistently get 1 for any value of a would be to raise it to the 0 power, right? Which means that this quite simply could be simplified to be 0. Number 21, I'll work downward here, starts with ln of 1 over e squared. So I'm going to split up my natural log. So I have natural log of 1 over e squared. So what I can do here is I can actually rewrite this with a negative exponent. So I can do ln of e to the negative 2. And just like we had before, I have natural log of an exponential, which cancel each other out, leaving me with just negative 2. For 22, I have, I'll use the lines. For 22, I have log base 3 of the cube root of 27. So I'm going to go ahead and rewrite this with a power instead of a root symbol. And I'm going to rewrite this as log base 3 of 27 raised to the 1/3. So, if there's an easy way to simplify this, I believe I know it. So, remembering my perfect cubes, I should recall that 3 squared is 9, and then 9 times 3 would be equal to 27. So the cube root of 27 is in fact 3. So I did not need to rewrite this at all. I'm actually going to go ahead and erase that. And this leaves me with just log base 3 of 3. And so 3 to what power gives me a 3? Well, that would just be to the first power. Number 23 is log of 0.01 cubed. So here I'm actually going to need to do a little thinking. So if I don't write anything for the base of a log, recall that this actually means log base 10. And so I want to know 10 to what power gives me 0.01 to the third. So there's a couple ways to go about this, but I'm going to do it the way that I best think about it. And I'm going to say, all right, in my argument of 0.01 raised to the third, I actually can rewrite this as, well, 0.1 raised to the third is, in scientific notation, 10 to the negative 2 raised to the third power. Or I can rewrite this as simply combining these two exponents, so I multiply the negative 2 and the 3, log base 10 of 10 raised to the negative 6. So now this is being log base 10, and this has a base of 10. I can simplify this to simply be negative 6. For 24, I have ln of e times the square root of e. So in order to simplify this one, I'm going to rewrite this as e times e raised to the 1/2. And I'm going to combine these two. So I would combine this to be ln of e raised to the, well, 1 plus 1/2 is e to the 3/2. And since the ln and e will cancel each other out, I'm left solely with 3/2. Finally, for 25, I have log, nothing is written as base, so it's base 10, of 10,000 raised to the 3. So again, I'm going to do the same process I did in 23, which is I'll have log base 10 of 10,000 can be rewritten to be 10 raised to the 1, 2, 3, 4th power. I'm just counting zeros there. And so 10 to the 4th power cubed can be rewritten just like this. And going one more step, combining these two exponents, 4 times 3 would give me log of 10 raised to the 12th power. Since there's no base written, that's log base 10. So these will cancel each other out. And that gives me a final answer of 12. Finally, for 26 and 27, I am expanding the logarithms. So all we mean by expanding here is breaking them apart if possible. So for 26, I have the natural log of square root of x squared plus 1. And I want to expand this if at all possible. So the first step I'm going to do is I'm going to say ln of x squared plus 1 can be rewritten with this 1/2 power instead of the square root. So I can actually take this 1/2 and pull it out of my natural log. So I can write this as 1/2 times ln of x squared plus 1. And really you can leave it just like this if you wanted to. I think I'm going to. 27, a little more complex, so I have log base 5 of, I'm going to use brackets here, x plus 5 in the numerator over the square root of x squared plus 1. So I can do two things here. First, I have a fraction in here, and so what I'm going to do is I'm going to break this into two pieces. So I have log base 5 of my numerator, which is x plus 5, and then I'm going to subtract what's dividing in here. So still with an argument of a log base 5 of square root of x squared plus 1. So I'm going to do the exact same simplification I did in 26 and rewrite this once more as log base 5 of x plus 5 minus minus taking this square root, making it a 1/2 power, and pulling it out front, minus 1/2 log base 5 of x squared plus 1. And I'm just going to leave it like this. I really don't need to simplify it any further.